Hello everyone, I am Saniya and in this video I'll be telling you and teaching you how to go from a tree, a probability tree, a nice little happy tree here. How do you go from this happy tree to a conditional probability distribution table, a CPD table? So please watch, please let me know if you have any questions, comments, or concerns, and I'll be happy to help you guys throughout. And please subscribe to my channel if you haven't. But again, this is sort of a continuation of a probability series videos on my channel. So in this sample example question, you may be given a problem like please give the conditional probability distribution table for the distribution of probability of D given A, B, and C represented by the tree below. So we see here that we have these three random variables. And then we also have this other one, which is a fourth one, D. So we already see here that we have these four random variables. So we have A, B, C, and D. So that's what we want to find here is how can we find the conditional probability distribution table for this tree. So you can see that we started out with A being F is for false, T is for true. Then we have B, false and true, C, false and true. And then this leads us to the given probabilities of D being true and D being false as well. But what they give you here is the probability that D is true, and then the corresponding probability would be the probability that D would be false here. So, if you want to find the probability D is false, here that's just equal to 1 minus 0.08, which is 0.2. Then similarly here, the probability that D is false is just given by 0.6. So that will be given by 20%. So this is the tips are just kind of telling you what is the probability that D is true or false. So you're given this information. So if A is false, then the next thing we see is if B is false or true. And similarly, if A is true instead, then we want to see is C true or false. And this is just for this example. So I just want to show you if you're given any tree, how do you find the conditional probability distribution? So that's like the main concern that we have here. How do we go from the tree to figuring out basically from this tree here? This is a little tree. How do we find this probability distribution? How do we find this table of values? So that's where we want to go from tree to values. And this is just an example again. We can have all sorts of trees, but I just want to show you this simplistic example for your convenience. So A, B, and C, these are Boolean random variables. They have true or false outcomes. And sometimes, we can refer to true as, as 1 and false as 0. Really depends. Sometimes the binary dummy. And the way I remember it is Boolean is like boo, liar. What you say is false. So for these, three random variables, A, B, and C, because they can each have two outcomes each. So we have 8 outcomes. So for A, B, and C, we have 2 times 2 times 2 outcomes, which is 8 total outcomes here. So these are 8 total outcomes that we are having for A, B, and C. So we can have false, false, and true. Now we can have A being false, B being true, C being true, A being true, B being false, and C being true, or A being true, B being true, C being true. So all 3 being true, or all 3 being false, or A being false, B being true, and C being false, or A being true, B being false, and C being false, or A being true, B being true, but C being false. So we have 8 total outcomes out there. And that's what we're going to also notice if we count the number of nodes as well. So what you'll notice from this table is that if A is false, but B is false, it doesn't really matter here in this stem what C is. For C is true or false here. So C is true or false. It didn't seem to matter on this end. If A is false, it doesn't matter, but given for this specific tree. But it doesn't matter here if B is true or false. It just matters what, like, that A was true, but what C is, false or true, seems to matter. And so on this end, and for this specific tree, again, so it really depends on the tree that you're looking at. But since B was not a part of the decision here for this tree node here, we don't care if B is false or true, it's the same. So, you know, if A is true and C is false, probability of D being true is 40%. So the probability D is false is 60%. So it doesn't really matter what that is. It sort of just matters what C is and what A is. So B can be true or false. The probabilities will hold the same here and here. But similarly, on this end, it doesn't matter if C is true or false. The probabilities will still hold the same. It doesn't matter exactly what that is, what C is true or false. If A is false, then you come here, and then if B is false, then you know, the probability that D is true is 80%. The probability that D is false will be 20%. It doesn't matter if, you know, whether or not C is true or false here. So this tree sort of tells you in a snapshot, like, what is the most important thing for this. You know, it doesn't matter what exactly C is. So if you see that, you could see that C could be, you could have even had another box where you're like C, and then it would be the same thing, true or false. Or true, it would be the same thing. It doesn't really matter there. So that's why they just sort of truncated it so you can see what really the decision-making process is composed of here. So ultimately, what we're going to see through this video is that this is the conditional probability distribution tree you converted into the table. So this is the table. So you see the variables A, B, and C, the three random Boolean variables, and these are the corresponding probabilities for D given the values of A, B, and C. So since there are these three random variables that are Boolean, so they can be true or false, you know, two outcomes for A, two outcomes for B, two outcomes for C are possible. So 8 total unique outcomes are here. 1, 2, 3, 4, 5, 6, 7, and 8. So for these 8 outcomes, we want to see what are the probability that D is also a Boolean random variable, so it can have true or false outcomes. So what's the probability that D is true or D is false? So these probabilities, you'll see is that from the answer, you know, so I'm showing you what the answer would be, but we're going to walk through them. Each of these will sum up to 1. Because it's a breakdown. So given these outcomes, so how you interpret this is that if A is true, B is true, and C is true, then D has a 50-50 chance of being true, but or false. So if A is true and B is true, but C is false, then what you have is D has a 40% chance of being true, but a 60% chance of being false. If A is true, B is false, and C is true, then D has a 50% chance of being true, 50% chance of being false. If A is true, B is false, and C is false, then we see D has a 40% chance of being true and a 60% chance of being false. And if A is false, B is true, and C is true, then what we see here is that we have a 70% chance that D is true, 30% chance that it's false, and the same goes here. If, you know, if A is false and B is true and C is false, then these are the probability distributions conditional for D. And lastly, what we see is that similarly, if A is false and B is false, whether or not C is true or false, D has a true or false here. Then also, so these two are the same here, but the difference is C being true or false. That D has an 80% chance of being true and a 20% chance of being false. So how do we get there, Yangshi? That's what we're going to talk about. How did we go and derive this conditional probability distribution table for D? So this is probability distribution table for D, conditional. So D given the values that we observe for A, B, and C. So I'm here with a cute little orange cat, and basically, and
Yankee and I will be going through with you about how we go from this conditional probability table tree to finding the conditional probability table here. That is, how do we go from here to here? So if you're stuck on any step of the process, then please watch this because I'll be going through step by step how do we go from this tree to this table here to figure out the probability distribution of D that is conditioned on what A, B, and C are. So if you don't understand this, please watch, and I'll be going through this with you guys step by step. Please watch, he's saying, please watch. So the first thing that we're going to do is we're just going to focus on a part of the table. So that is what we're going to do is essentially we're going to focus on, like, for instance, what happens, so part of trying to go from this tree here to this part here is sort of seeing what happens if we focus in on a certain part of the table. So let's, for instance, look here and say, okay, let's just forget this part of the table for now. Let's just focus on the situation here where A is false. So that being said, we're just going to look at, okay, A being false, which just takes us to this part of the table. So we're going to black out this part here. We're going to black out all the stuff here, just black it all out. And we're just going to focus on when A is false. So when A is false, what we say is it doesn't really matter if C is true or not for finding the probability of D. It doesn't matter if D is true or not. That is essentially what we see here is that we're just focusing on this part of the table. So when A is false, what we will see is that for this part here, you're going to notice that true or false, the results here tend to be the same in twos. And similarly here, for true or false for C, the results tend to be in pairs. You know that you're seeing that the probability is 0.7, 0.7, 0.3, 0.3. But the only thing that changes for these green rows is the probability is the value of C being true or C being false. And here the value of C being true or C being false, but you know 0.8, 0.8, 0.2, 0.2. And that is because if we look at this part of this table, C does not even factor in. We're just looking if A is false. So what you also notice here is that throughout A is false. And that's the main thing. A is false. Whether C is true or false, it doesn't seem to make a difference here. It doesn't seem to make a difference here. But what really makes a difference is the value of B here. So you see here that when B is true and true here, what we notice is that A's are always false. So don't even worry about them. So let's just focus our attention here to this part of the table. And let's just see, okay, well, in these two parts, we notice that B is true here. And in these parts, we notice that B is false. So that just goes down to this idea that here A is true, is false. Then we look at B. If B is true, then the probability that D is true is 0.7, which is what this value is right here. So right here, this 0.7, this 0.7 comes from here. And that's what this 0.7 comes from right here as well. That basically, if B is true, then, if this is the case, then the probability that D is true, the probability D equals true, is going to be 70%. And then this probability is just 1 minus this value here. So it's going to be 30% and 30% here. And similarly, if B is false, then the probability that D is true is 0.8. And this probability of 0.8, this right here is what this is. And then whatever this column is right here, this column right here is just the same thing as probability D equals T. It's just 1 minus this. And this column right here, guys, this column right here is a probability D equals true. But it is conditioned on the other values. The values of A, the values of B, the values of C. It's conditioned on all of those values. So that's what these probabilities are. They're conditioned on the values of A and B. And here C did not matter. So whether C is true or false. So because C wasn't part of the calculation here for this root, we want to consider all possible values of C, the true value, the false value. So we didn't see any, pun intended, we didn't see any C here. So that's why we want to kind of consider it in our calculations. So we want to not just have A and B, but we also want to say, okay, if C is true, then the same thing holds here, whether C is true or C is false for this probability. And same over here too. If C is true or false, we want to consider that. So that's basically what we see here, is that whether C is true or false, as long if A is false and if B is true here, it doesn't. So that's what we observe here, that if A is false and B is, so A is false is all of these. That's what the condition is. A is false, then whatever C is. So here, if C is true or C is false, it doesn't matter. The probabilities hold for probability that D is true. And the same here then is, so they didn't write this, but you can see actually, and Yankee, you can see here the probability that D equals false is just 0.3. Oh gosh, my handwriting sucks. It's 0.3. So that's what, this is 70%, then the probability D is false is just 30%, which is what this is over here. And similarly, if probability D equals true is 80%, which is what this is here, then the probability that D is false is 20% here. But this, in this situation, A is false and B is false. So A is false here and B is false, and we don't know, C doesn't matter here. So the same probability holds whether C is true or C is false. So up next, we're going to similarly talk about the right side of the table, which is when A is true. And we're going to get rid of, sorry little guy, we're going to get rid of all of this part here. And we're just going to focus on this part. So we're going to slash out all of this part here when A is false. We're just going to focus on this part right here, which is when A is true. That is, we're just going to focus on this right side of the table, which is where A is true. So that's what you're going to notice about here. Similarly, we're just focusing here where A is true. And all of these are A is true, so you can just ignore that part. And now, similar to the other example, what we just see is that there's A and then there's C, and then we have the probabilities for D that are conditioned on A and C. But here we also have B, which plays a role, but B does not seem to matter here. If A is true, then the one thing we need to just consider is whether C is false or true according to this, tree. So it's really dependent on the tree that you get. So, but in this case, because there's no B that is used from A to C, so if there's ever a random variable that is not on a journey, on a certain journey to the end, to the leaf, if you think of a cute little tree, like this, it's a cute little tree. And this is like a little tree here, for instance, right? And then you can see this little leaf. It's a little leaf there. So in any case, if there's any random variable that is not on the journey, then you can just say, okay, if it's a boolean, so boo liar, like boolean. So if it's a true or false, so since B was not on the journey to the end here, we're just going to control for the values of B here. So essentially, what you're going to see here is that if A is true, so okay, A is true, so we can ignore that point, just focus on what B and C are here. So if C is true, then the probability that D is true is 50%. And then I also just filled in the probability that D is false is also 50% because these need to add up to 1. These also add up to 1. The probability D can be either true or false because it's a Boolean. So if D is true is 40%, then the probability that D is false is 60%. 1 minus 0.4 is 60%. And similarly, if probability D is true is 50%, then probability that D is false is also going to be 50%, which is 1 minus 50%, which is what this is here. So what you're going to see here is that on this journey, when A is true here, so let's just ignore this part for now. What we see here is that, okay, if C is true, so where is C true? C is true here and here. So if C is true, then the probability D is true is 50%, which is what this is, and the probability D is false is 50%. So we have these two rows, and you might wonder, okay, well, why do we have these two rows? Well, we have these two rows, so A is true and C is true, okay? A is true and C is true is also true for this row here, for these two rows here. A is true and C is true. A is true and C is true. 50%, 50%, 50%, 50%. Well, what are the difference? Why do we have two rows? Well, the key difference comes down to this having B is true. Oh, the difference is that here B is true and here B is false. That's the main difference because we don't need, it doesn't matter whether B is true or false, but since it wasn't part of the calculations down here, we just want to basically show that, hey, so if you are looking at this table, and I'll be making another video for how to go from this table backwards to the tree, so now you can see both sides of it too, but the idea that you can get from here is that, hey, it doesn't matter whether B is true or false, as long as A is true and C is true, this will hold that, you know, you have a 50-50 chance that D will be true or false here. You'll have this. That's all that we're gathering. That's all that we're gathering here. It doesn't matter whether B is true or false because it wasn't part of the decision. You're going to include both values. And this can extend to when there are multiple random values for a variable. If it wasn't part of the tree calculation, then please just control for any value of it because whether B is true or B is false, because B is a random variable, it's one of those parents of D here. D is going to be dependent on what B is because of the other side of the tree at some point. So it doesn't matter because B can be true or false and you'll still get the same probabilities. But please remember on the left side of the tree, it was reversed. Given this tree example, again, it's very example dependent. But on the left side, instead, B was important and C wasn't. So here on this side, B is not important, but C is. So we're just controlling for both values of B here. And that's what you're also going to observe if you see when, pun intended, if you see when C is false, then we will have 40% chance that you're going to see the same thing here play out where, you know, A is true and C is false, and again A is true and C is false, and the probability D is true is 40% here, which is what this is here. This again, guys, this part maps to the same thing here. This 40%, so the probability D is true is 40%. And the probability D is false is 60%. And again, these, you know, if you sum up the rows, they add up to 1, add up to 1, add up to 1, add up to 1. 50 plus 50, 40 plus 60, 50 plus 50, 40 plus 60, they all add up to 100% or 1. So basically what you'll see is, again, these are the same values, but we were controlling on B being true and B being false because these are both outcomes of B. So essentially it's saying that no matter whether B is true or false, as long as A is true and C is false, then D has a 40% chance of being true and a 60% chance of being false. So that's how you can kind of interpret and get this probability table. So this is the probability of D given the values of A, B, and C. So D is dependent on these. So the first thing that we're going to do is we're just going to focus on a part of the table. So that is what we're going to do is essentially we're going to focus on, like, for instance, what happens. So part of trying to go from this tree here to this part here is sort of seeing what happens if we focus in on a certain part of the table. So now, Yankee, I just want to summarize some of the core concepts that we talked about today. So just like a bedtime story, or like one of my favorite ones, my mom Poochie used to read out, is on Walter, no jumping on the bed, the three piglets, SpongeBob and his grandma. So just like a bedtime story, just a little recap, a little story about what are the main concepts that I was trying to teach you guys in this video here. So the first one is that we have these 4 random variables that are Boolean, like boo, liar, A, B, C, and D. And D, the variable D, it depends on 3 Boolean random variables that are true or false. A can be true or false, B can be true or false, C can be true or false. And as you go along each of these outcomes, you have to see what are the probability that D is true or false. So this side here, we see that we just need to go along A being false and B being false or true here. So it does not, and we have an outcome for D, so it does not matter here if C is true or false. And similarly, on this side of the table here, of the tree, if we go on A being true and then C, it does not matter if B is true or false. And similarly, according to the rules of probability, the probability that D is true plus D is false equals 1. So we are given all these probabilities here at the bottom, the probability D is true, etc. So when we're given these probabilities that D is true, D is true, D is true, D is true, it's important to remember that the probability that D is false is just equal to 1 minus the probability D is true, because they sum up to 1. So if the probability D is true at this outcome is 80%, then the probability D is false is just 1 minus 80%, which is 20%. So this probability is 20%. This probability that D is false is 1 minus 0.7, so that's 30%. Here the probability D is false is 1 minus this 40%, so it's 60%. And lastly, since the probability D is true is 50%, then the probability D is false is also 50%. So it's important to remember that these probabilities add up to 1. So if you're given one of them, you can derive the other. If you're given the probability D is false, you can derive the probability that D is true for that outcome. And from all of this, you're supposed to derive all 8 probabilities, because there are 2 outcomes for Boolean random variable, and there are 3 of these variables, A, B, and C. So 8 possible outcomes for them that I have listed before. So from them, you're supposed to kind of determine the probability that D is true and false given these others, because these others are shaping it. And again, on this side of this tree, C does not play a role. Whether it's true or false, it doesn't matter. And here on this side, B does not play a role. And this is very dependent on the specific tree that we have. But again, at each root, if I give you one probability, then you can find the other. So then in short, you can see the probability D is true and D is false. For each of these outcomes here, they sum up to 1. So they sum up to 1, sum up to 1, sum up to 1, sum up to 1. So from this, you're supposed to derive all the 8 possibilities that are out there. So here, we start off with A false, B can be false, and C can be true or false. So that's how you'd get it. So when you go along here, this route here, instantly for the outcomes you see, okay, A is false. So if you have A, B, and C here, you would instantly list this as being A is false. And then let's say we go along here, then we have that B is also false. And since C doesn't matter what it is, we have 2 outcomes. C can be either true or false here. So C can be true or C can be false. Either or between the 2. But from these variables, we're supposed to then define the probability distribution for D. So for D, we have the probability of being true or false. So from here, we then have the probability of true and the probability of false for D. That's sort of what that table is giving us. So we had these three random variables. So if we go along this branch, A is false, B is false, and it doesn't matter what C is because we get some outcome here for D. D is true and D is false here. So that's what we can get here. Probability that D is true will be 80% and probability that D is false is 20%. That's what we would get from this part here. And so we can enlist, so from this one, we are having two outcomes here because C, we have one outcome for A, one outcome for B, and two possibilities for C. And similarly here, this would be A is false, B is true, and C can be true or false. So and then what we would put here is that probability D is true is 70% and probability D is false is 30%. So that's sort of how we go through this table here. And in this case, again, on the left side, it doesn't matter what C is. C can be true or false here. It didn't matter as long if A is false, then B is the next important thing. And on this side, if A is true, then according to this tree, and again, it's very specific on your tree, so I hope I can teach you the concepts in general. But if C is, so if A is true, then we look at C, and then we see if it's false or true. It doesn't matter what B is. So how you would interpret these probabilities is the following. So if you see this, again, we saw that these two have to sum up to 1, but how you interpret this is this is the probability D is true given. So when we look at the givens, we sort of see where did we come from. So A is true given that, so this is the probability that D is true. What I've selected is the probability that D is true, but it's conditioned. It's given that, and then when you look at the given that, you look at the journey that you took to get to this root here. We look at the journey, and the journey that we've taken is that we've looked at A being true here. Oh gosh, let me do a better job. We looked at A being true here. A is true. Then we also saw that C is false. Oh, maybe that's not a good color. But I just underline it here. C is false. Okay, so this is basically the probability that that D is true given that A is true and C is false, and B was not part of it, so B can be either true or false. And what we see, because we see just A is true, C is false, there is no mention of B on this side of the tree again, so we don't need to worry about B. So if A is true and C is false, and B can be either true or false. So what is the probability that D is true? That is going to be 40%. So the probability that D is true, that we get this true value, given that A is true, T for true, and C is false, and B can be either true or false, but we need to mention that, is 40%. So that's what this is saying. Probability D is true given that A is true, C is false, and B is true or false is 40%. But we want to write this out cleanly, so we're going to just break this part into two. That's it. And this part is all the same here. The only difference is that here B is true and here B is false. So we just enumerate the two options because we want to essentially, I'm going to show this in another video, but you're going to see that if you observe something like this, where everything else being the same, but this variable being true or false, you're listing it out over its outcomes, it doesn't make a difference. It sort of says that here, given these other variables, B doesn't make a difference. And that's how you would represent this thing in a tree here, is you would say, hey, when B is true or B is false, those are both possibilities for B. B can be either true or false since it's a Boolean variable. It can be either true or false. And if that's the case, it doesn't seem to make a difference on this probability that we observe. So it must not involve B. But we still need to list this out, both of them. And then when you guys get better at this, you'll see that it doesn't matter. That's what you can learn from here, is that B being true and B being false, it doesn't impact this journey over here. And Similarly, so if D is false, again, you guys see that these add up to 1. So at each root, if D can be either false or true, false or true, false or true. So if now this is the probability that D is false, given the same thing, A is true, C is false, and B can be anything. So the probability D is false, given that refers to this journey. So we saw if A is true, and then if C is false, that's this probability. And B does not matter here. So we split this true or false up into these two statements that are the same, basically. So yeah, just to tie up again, this is just on the other side. So here, this is the conditional probability of D, given the probability of D being false. Here is 30%. So what you see here is C does not matter on this side. So A is false is what we're going with. And if on this side B is true, then C can be true or false here. So this is the probability that D is false given that. So again, this bar means given that, what you're conditioning on. Given that A is false here, A is false is like this part. A is false. Oh wait, let me represent it better. A is false. That A is false. Okay, so you can see that there. A is false. Maybe I'll just underline it. And A is false here, and B is true. And it doesn't matter what C is, but what we see here is that A is false and B is true, so B is true. So that's what we're going with. So A is false and B is true. And it doesn't matter what C is here, because we got to the leaf, we got to the end of the tree without worrying about it. So if A is false and B is true, C can be true or false. So probability that D is false, given that A is false, B is true, and C can be true or false, it is 30% here. C does not matter here. So that's what we see here. Since C, pun intended, since C can be true or false, again, we just break it apart into the two outcomes just to list it neatly. So the interpretation is the same. So C can be either true or false, it doesn't matter. But we just break this part into two statements just to make everything neat here. And that's what we represent here. So again, these are the 8 outcomes from before. 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes for 2 random variables. Not 3 random variables, 2 outcomes each is 8. And what we see here is if A is false here, B is true, and C can be true or false here. We're looking at this 30%. That's what this is, a 30% chance that D will be false given these values of A, B, and C. This is the conditional probability table for D, 30%. And then you can similarly see that if D is instead true, this probability becomes 70%. So the probability D is true given that A is false and B is true, and C can be either true or false. It's 70%. So again, we split this up into the 2 outcomes, and we can see the same thing here. We have 2 rows because these are the same, but we're just enumerating on T or false for the for C, and this is the 70% under. So D has 70% and 30%, but these add up to 1. So this is just a summary of how we go from the tree to a conditional probability table. So all in all, I hope that I was able to show you how you can go from a probability tree to finding the conditional probability table that represents it. So here it's conditional because these values are very, very much dependent on the values of the random variables of A, B, and C. So hopefully you can now see how we can go from the tree to a conditional probability table. And Yang, she's also super happy that you learned those skills.
So thank you for kind of watching that, how we can figure out the random values of A, B, and C, how they can influence the random value that we observe for D. So that's what we can see here. So the probability of D given A, B, and C, true and false, how we can observe those for any value of A, B, and C here given this tree. And this will be very dependent on the tree that you have. Thank you for watching this. Please subscribe for more updates. Yangshi says hi. Hi. Hello. Thank you for watching this. Please subscribe.